So the next concept here is the angle between two polar curves. All right. Angle between two polar curves. Okay. Now the basic concept is this: in in any geometrical problems, uh, our intention is to calculate the angle between any of the two curves. Okay, which means the two curves which we are considering must intersect at some point. Okay, so let's consider a diagram first, just to understand what exactly we are looking for here. Okay, let us assume that we have the original x and y axis with us, though we are not using these x and y coordinates. Okay, now let us consider that we have two different curves. Okay, so let us say the first curve I'm going to draw is this one. Okay, let me say I have a curve like this. Okay, and I also have say another curve like say this one. Okay, now we know that they are intersecting at a given common point. Okay, this is the point of intersection. So let me denote that point as P. Right now we are in the polar coordinates, that's why it is r comma theta, right? Okay, now if I want to draw the tangents, because see how we measure the angle between the two curves, it's nothing but we can measure that by simply using the tangents of both curves. Let's draw the tangents first and then we'll see how to measure that. Okay, so let me draw first tangent. Okay, let me use a different color for tangents. Okay, for the tangent, one of the tangent I'm going to use, let me say, let's use a red color. So let me say that this is the tangent number one. Okay, tangent number one. All right, let me call this as say T1. Also, I need another tangent. Let's say it has to pass through this. That's why I'll draw here like this. So see, this is the second tangent. So we'll call this as T2. So this side is T1, this is T2. Okay. Now I want to calculate the angle between the two curves, which means I am supposed to find out the angle between these two tangents itself. Okay, so that is my objective. So see, I want to calculate this angle between these two tangents, which I'm going to denote it as alpha. Okay, so now this is the idea. Basic idea is this. Let's try to connect the coordinate axis, that is origin. Let me denote that as O. Let me connect the origin with the point P first, because that's the radius vector. Right, why I'm doing this is because I already know some concept, right, using which I can extend the same concept to find out this alpha. Right, now from the basics, right, I know something, that is angle between the radius vector and the tangent I know already. So for example, this angle, see, angle between this radius vector and the first tangent T1, I know that. I have an equation for that. That is nothing but phi 1. Similarly, right, let me denote this as R. R and this is theta. I know this. Okay, fine. Now, using the basic concept, I also know this angle. Right, this angle is angle between the radius vector and the second tangent. Let me denote that angle as phi 2. right? We already have the basics equations available with us. Using that we can calculate. Okay, now see, this is the one. In order to calculate that, I might need this angle, right? From our basics we know that this is denoted as psi 1, and I'll also denote the second angle as psi 2. So now if you look carefully, right, this angle, I'll change the color. So this angle alpha is actually the difference between the phi 2 and phi 1. From phi 2, if you subtract phi 1, you are going to get the alpha, right? So that's the very basic idea now how to calculate the angle between two curves. When I have two curves, right, you find phi 1 of the first curve, phi 2 of the second curve, and take a difference, right? So using that concept, this is a very basic concept. Now we are going to apply in our problems so that we can solve, right, different problems of this particular type. All right, now let's go to some of the basic problems. So problem number 1 is this. Okay, before that I want to discuss another point here. This point will help us out in understanding the concept in little bit more detail. Okay, so that concept is like this. So let me write the equation once now. So the equation is like this. So angle between if alpha is the angle between two curves. What are the curves? Let's denote the curves by some name. Say R. This is R. R is equal to f1 of theta. That's the first curve. And second curve, let's be R is equal to f2 of theta. All right, these two are the curves, right? This implies we know that how to calculate this. That is, alpha will be equal to it can be phi 1 minus the psi 1 minus psi 2 or phi 1 minus phi 2. So let me denote it as a magnitude. So phi 2 minus phi 1. We are interested in only the magnitude of the angle, not in the sign. So what we do, we try to represent alpha is equal to phi 2 minus phi 1. All right, now there are two different varieties of problems that can come in this. All right, so let's look at the two cases. So first one is simply like this. In the sense, if you are able to find the phi 1 and phi 2, maybe in terms of theta, right, angle between them can be easily calculated. That's what is the case 1. Case 1 is the above one itself, right? So but I write in statement here. So if we get phi 1 and phi 2, because previously when we solved problems we understood that we can solve, right, we can get the angle phi in terms of theta. So phi is equal to theta plus pi by 2, phi is equal to theta minus something like that we got, okay, in the previous problems. So what we do now, we try to represent the phi 1 and phi 2 in terms of theta. Let's assume if we get phi 1 and phi 2 in terms of theta, right, this implies represent alpha as simply phi 2 minus phi 1. This is, it's a magnitude function. Okay, so we'll calculate this. That's the case 1. Then case 2. Okay, now let us say that we don't have any access to this function. I'm not able to find the phi in terms of theta, right? So if phi 1 and phi 2 can not be expressed in terms of theta. I'm not able to represent that in terms of theta, right? What we do, right? Then what's the solution? Because still I need to calculate the angle, right? Somehow I need to do this. So what is the solution? The solution is like this, right? What we do, we first try to find, this implies somehow find the tan of phi 1 and the tan of phi 2. Somehow we need to find this. Now we have two options to proceed. What I do, I take a product now, tan phi 1 into tan phi 2, right? Tan 5 into phi, if two tans you take and you multiply, and if the answer is -1, then they are actually orthogonal. Okay, that's the concept we already have studied in PU level mathematics, right? If you multiply tan of two angles, right, and you get an answer as -1, then they are orthogonal to each other. The sum is 90 degree, that's why. Okay, so we'll write a condition: if tan phi 1 into tan phi 2 is equal to -1, right? Because the slopes, tan phi 1 is slope of the first curve, second curve is tan phi 2, slope of second curve. So if the slopes are going to get the, when you multiply the slopes of two curves, you get -1, means the curves are orthogonal, right? So that's the point. Curves are orthogonal, right, to each other, in the sense they intersect, making an angle of 90 degree or pi by 2. But let's say I don't have that answer coming up, in the sense tan phi 1 into tan phi 2 is not -1. In that case, what we have to do, we'll calculate the tan alpha. So because tan alpha is nothing but, this is tan of, anyway, I know that alpha is equal to phi 2 minus phi 1. I'm going to take the tan of that now. If I know something very basic, right? What is that? If you have, say, tan of A minus B from trigonometry, I can write it as tan A minus tan B whole divided by, this is 1 plus tan A tan B. This is something very basic. Okay, this equation we are going to use now. I'll just highlight this like this. So I'm going to use this property now. So when I use this, I can write this answer as, this implies I have tan alpha on the left side, that is nothing but, it's the magnitude of tan phi 2, because A looks like a phi 2 for me, minus this is tan phi 1 whole divided by, this is 1 plus tan phi 2 into tan phi 1. That's the answer. So I can find it either using case 1 or case 2. Two options we have. Sometimes you get the answer directly in terms of theta. Then you can simply take a difference, take a magnitude, that's your alpha, which is case 1. Case 2, I'm not able to represent in terms of theta. In that case, I have only one solution: find a tan of both the functions. If you see, check that whether the product is -1 first. If it is -1, they are orthogonal, no need to prove anything. Otherwise, right, use the tan alpha function, right? That's what we have written just now, this one, to calculate the tan alpha. Then take alpha is equal to tan inverse of that function. All right, so these are the options we have when it comes to the solution of this. Right, so we'll solve few of the problems based on this concept. So always the question will be something like, find the angle between following curves. Okay, this is the basic question. Let's say first one is r to the n is equal to a to the n cos n theta. So r is equal to a function of theta, we can see, and the other function is r to the n, and r to the n is equal to, say, b to the n sine of n theta. Okay, so my objective is to find phi 1 and phi 2 first angle, then I'll try to take the difference between those two to get the final answer. Okay, so first I'll take the first curve, that is r to the n is equal to a to the n into cos of n theta. This implies, what's my first step? So recall what we did in the previous session, where we solved the problems to calculate phi 1 or simply phi. So what we did, we took log on both sides. So now you don't have to write everything in detail now, because we are familiar with this. Directly take the log. So that means it is n log r is equal to n into, this is log a, plus log of cos n theta. Alright, after this, my next intention is simply to take a derivative, right? Differentiate both sides with respect to theta, right? So we'll write that, differentiate with respect to theta. So what happens now? So n is a constant and remains as it is. Log r is 1 by r into, this is dr by d theta. Dr by d theta is equal to, so this is 0, constant, that's why it is 0. Log of cos theta is 1 divided by cos of n theta into derivative of cos n theta is nothing but minus n into sine of n theta. So I can say that everywhere I have n which is common, I'll cancel that. Then 1 by r dr by d theta is nothing but, this is cot of phi. So first curve, so I'll denote as phi 1. Cot phi 1 is equal to, this is minus sine by cos is tan. So cot is negative. Cot is negative in which quadrant? If you remember, it is cot is negative in the second quadrant, which means it has to be pi by 2 plus something, right? So in order to, if I have cot phi 1 is equal to cot of something, then I can actually relate. That's why. So how do you identify that? You just have to look at the sign. If it is negative, then you have to identify the quadrant where this cot is negative. First quadrant it is positive, second quadrant it is negative, so it has to be second quadrant. Okay, in second quadrant, cot and tan are equal only if it is 90 plus something. 90 plus and 270 plus is this. 90 plus or minus is fine, but 90 minus is not possible. 90 minus means it is first quadrant which is positive, but it is negative now. I marked with a red color, which indicates that this particular function now has to be 90. So 90 is pi by 2 plus n theta. Okay, so this has to be 90 plus n theta. So cancelling the cot on both sides, this implies the angle phi 1 is equal to pi by 2 plus n theta. So we got the angle of the first curve, angle made by the tangent to the first curve. Right, that's what we got. Then let's go to the second function given in this problem. So the second function given here is r to the n is equal to some other value, so b to the n into, now this is sine of n theta. So taking log on both sides, this is n log r is equal to, this is n log b plus log of sine of n theta. All right, so now differentiating with respect to theta, right? Whenever we differentiate with respect to theta, we get this. right? This is n into 1 by r dr by d theta is equal to, this is differentiation 0, now plus log of anything is 1 divided by the same thing, so it is sine function, so this is sine of n theta into differentiation of sine is nothing but it is n into cos of n theta, so n cancels. Now what happens is on the left hand side I have cot, it's a phi, but second function I call it as phi 2. Okay, cot phi 2 is equal to, now you see this is cos by sine, which is cot of n theta. So cancelling the cot on both sides, the phi 2 becomes equal to simply n theta. This is the value of the phi for the second function. All right. So now what I want, I need alpha. Therefore, angle of intersection alpha is given by magnitude of phi 2 minus phi 1. That's the equation. So let's denote. This is equal to magnitude of phi 2 is n theta minus phi 1 is nothing but this is pi by 2 minus pi by 2 plus my mistake plus n theta. So this means n theta and minus n theta will cancel. Magnitude of minus pi by 2 is pi by 2. So angle of intersection is in this case 90 degrees. So alright, so that's the first problem. Let's go to the next problem in this case. Okay. So the curves are r is equal to, this is a theta divided by 1 plus theta. Okay, and the second function r is equal to, this is a divided by 1 plus theta squared. Okay, so by default we are supposed to calculate the functions one by one. So let's start with the first one, that is r is equal to, this is a theta by 1 plus theta, right? I need log r, so we'll take log. Okay, so that means this is log r is equal to, this is log a plus log theta minus log of 1 plus theta by applying the basics of logarithm. Numerator there is a product, so product becomes sum. If you have a denominator, that becomes negative log and you write as it is. That's why 1 plus theta is in the denominator, right? Its log is negative minus log 1 plus theta. All right, next step is to differentiate. Differentiate with respect to theta. So what happens to r? R becomes 1 by r dr by d theta is equal to log a, it's 0. Okay, theta is 1 by theta because differentiation happens with respect to theta itself. If it is log x, 1 by x, so log theta is 1 by theta. Next, log minus log of 1 plus theta becomes 1 by 1 plus theta. Okay, so now let's do this. So 1 by r dr by d theta is 1 by r dr by d theta is nothing but this is cot phi 1, correct? So cot phi 1 is equal to, take a common denominator here, this is 1 plus theta minus theta whole divided by theta into 1 plus theta. This is the common denominator. So this theta and this minus theta will cancel out. So cot phi 1 becomes equal to 1 divided by theta into 1 plus theta. Let's hold on to this. Let me call this as equation number 1. So now what I should do in the next step, I have to consider the second curve. So the second curve is r is equal to, this is a by 1 plus theta square, right? So taking log r is equal to log a minus log 1 plus theta square. So differentiating with respect to theta, this is 1 by r dr by d theta is equal to, what happens now? This is log a becomes 0 minus 1 by 1 plus theta square into differentiation of 1 plus theta square is 2 theta, right? So this means I have minus of 2 theta divided by uh, okay, minus 2 theta by 1 plus theta square. Okay, now you see that we got the functions in terms of, okay, let me write it once again. So this means cot of phi 2 is equal to minus 2 theta divided by 1 plus theta square. Now I am not able to find the phi 1 and phi 2 in terms of theta. Directly it's not available. It's, if you want to find phi 1 and phi 2, it's cot inverse of something. So it's not possible to solve. So this becomes the second case of the problem now. So what I do, at the point of intersection, both the curves are same. Okay, in the sense, this is first curve. Let's say this is the second curve. At this point, right here, right, the f1 of theta, that is r1, r is equal to f1 of theta becomes equal to f2 of theta, correct? Because it's the same point. So first curve and the second curve meet means both of them are equal at that point, right? So now let's hold on to this cot phi 1 and the cot phi 2. Let's hold on to this. We'll resume it later, but for the time being, let's say I want to find out at which point I'm having the intersection of those 2 points, those two curves, right, happens at which point I want to find first. So only then I can get the value of phi 1 and phi 2, or tan phi 1 and tan phi 2. Okay, only in that case I can find. So for that reason, so I'm doing this step. This is the addition step now. At the intersection, both curves are equal, right? So when both curves are equal, I can equate them. How do you equate? This implies first curve, you see, this is a theta divided by 1 plus theta. This is the first curve. This is equal to a divided by 1 plus theta square, right? So a and a I'm going to cancel now. So I'll cross multiply. So theta into 1 plus theta square. Let's take 1 plus theta, only square applicable only for theta. So equal to, this is 1 plus theta, because a is cancelled already. So I simply move the 1 plus theta to other side. This means this is theta plus theta cube is equal to 1 plus theta. So theta cancel. So theta cube is equal to 1, right? Which means the theta is equal to, we have multiple answers, you take only one, right? Theta is equal to 1. Now I got theta value. So in case 2, if you look at the case 2, I'll go back to the two cases. In case 2, you can see that if tan phi 1 and tan, first, whenever we are not able to represent the phi 1 phi 2 in terms of theta directly, take tan phi 1 and tan phi 2. So how do you get tan phi 1 and tan phi 2? You see, we have in this problem, we have cot phi 1 and cot phi 2. So cot phi 1 is given equation number 1. Cot phi 1 is 1 by theta into 1 plus theta. So let me write that now. So that is cot phi 1 is equal to 1 by theta into 1 plus theta. This is what we have proved. This implies, how do you find tan? Simply take the inverse, because tan and cot are inverses of each other. This implies, now tan phi 1 is equal to simply theta into 1 plus theta, right? I know that, right? Theta is equal to 1. Just now we proved at the intersection point theta equal to 1. So theta equal to 1 implies, what is tan phi 1? Tan phi 1 is 1 into 1 plus 1, so that is equal to 2. Okay, similarly, let's go to the second angle, that is cot phi 2. So we know that what is cot phi 2? Cot phi 2 is equal to minus 2 theta by 1 plus theta squared. So cot phi 2 is equal to minus 2 times theta divided by 1 plus theta squared. So this implies what now? This implies I can find tan phi 2 as inverse. Inverse is minus of 1 plus theta square divided by 2 theta. So now I already know that theta is equal to 1 at the intersection point. So calculate what is tan phi 2. So tan phi 2 is minus of, this is 1 plus 1 whole divided by 2. Right? So numerator is 2, denominator is 2, and minus is there, so this is minus 1. Now in the case 2 of the problem, we already have discussed that, right? That is, we have an equation for tan alpha. So tan alpha is equal to magnitude of tan phi 2 minus tan phi 1 whole divided by 1 plus tan phi 2 into tan phi 1, its magnitude. Now simply substitute. We already have the values. So tan phi 2 is minus 1 minus tan phi 1 is 2 whole divided by, this is 1 plus 2 into minus 1, its magnitude. So numerator is minus 3 divided by, this is minus 2 plus 1. So minus 2 plus 1 is minus 1. So this is 3 by minus 3 by minus 1 is plus 3. So we have 3. So tan alpha is equal to 3. That implies I can directly calculate the alpha now. Therefore, alpha is equal to tan inverse of 3. Alright, we can actually calculate its value in tan inverse of 3 in a calculator, and we can write the answer. That's also fine, but anyway, it's understood, right? So that's the final answer. Okay, so this process has to be practiced, because most of the problems that appears in our exams are of type 2, because type 1 is very straightforward, anybody can solve it. Okay, so but the type 2 problems are slightly difficult, right? They are different level problem, so we need to practice more. Okay, so now let's solve another problem of the same type. That's a type 2 question. This is equal, let's say r is equal to a log of theta, and the second function is r is equal to, this is a divided by log theta. Okay, our first intention is to calculate phi 1 and phi 2, if not calculating tan phi 1 and tan phi 2. That's our first objective. Okay, let's do that. So for the first function, that is r is equal to a into log theta. So what do we do now? We take a log on both sides. So log r is equal to log a plus log of theta. So this is log of log theta. Then we directly differentiate. When you differentiate, this is 1 by r into dr by d theta is equal to log a, differentiation is 0, plus log of whatever is 1 by that, so 1 by log theta into differentiation of log theta, which is 1 by theta. what is there on the left hand side? Left hand side we have cot. So this is cot phi 1. Cot phi 1 is equal to, this is 1 divided by, right, theta into log theta. So let's remember, anyway I am not able to find the phi 1 directly in terms of theta. I have to take a cot inverse on the right side, then only I get this. So that means it's not type 1 problem, it is a type 2 problem. So my intention is not to find phi now. It is better I find the tan now. So I keep the tan ready. So that is tan phi 1 is equal to inverse of the above equation. So theta log theta. So call this as equation 1. I got a tan function now. Similarly, I need to find a tan phi 2, for which I am going to use the second function, that is r is equal to a divided by log theta. Okay, r is equal to a divided by, this is log theta, right? So what do? I take log on both sides. So this is log r is equal to log a. Denominator's log is negative, so this is minus log of log theta. Okay, differentiation is going to get me here, that is 1 by r dr by d theta is equal to, we have log a differentiation is 0 minus log of that, so this is 1 divided by log theta into 1 by theta. So this is very clear now. Cot phi 2 is equal to minus of 1 divided by theta into log theta. Okay, let's go ahead. This implies, now what is tan phi 2? So tan phi 2 becomes equal to, it's inverse of the above function, that is minus theta log theta. Okay, let's call this 2. Right, now once recall the previous answer. Once we find the tan phi 1 phi 2, our intention is to find the point where both the curves intersect. So at the intersection, what happens? Both the curves are equal, correct? So first curve is a log theta, and the second curve is a divided by log theta, right? So a cancels. I take log theta to the same side, that means log theta the whole square is equal to 1, because right side a was there, it's cancelled, now there is 1. So log theta square is equal to 1. This implies taking the square root, log theta is equal to root of 1, which is 1. So log theta is 1 means we need to take the anti-log is e to the power. Okay, so that means if you raise both sides e to the power, I get theta on this side. Theta is equal to, this is e to the power 1, which is e. So now what is the intersection point? Intersection point is theta is equal to e. So when theta is equal to e, now I am supposed to find out the values of tan phi 1 and tan phi 2. Alright, so theta is equal to e implies this, at this point where the intersection happens, what is tan phi 1? I go back and check my equation number 1. It says that tan phi 1 is theta log theta. So this should be theta. Theta is e log e. So log and e are inverses of each other. So log e is 1. So this is e into 1. That is e. So tan phi 1 is equal to e. Okay, similarly, let's go for tan phi 2. So let's just check the phi 2. So tan phi 2 is minus theta log theta. So this is minus e log e. Once again, this is minus e into 1, which is minus e. So tan phi 1 and tan phi 2 both we got. So This implies, how do you calculate the alpha now? So I don't get the alpha directly. I use tan alpha. Tan alpha is equal to, let's write the equation, right, so that we get familiar with. This is magnitude of tan phi 2 minus tan phi 1 whole divided by 1 plus tan phi 2 into tan phi 1. So substitution, tan phi 2 is minus e, tan phi 1 is also e, that's minus e minus e. This is 1 plus tan phi 2 is a minus e, and tan phi 1 is e, its magnitude. So this implies magnitude of minus 2e divided by 1 minus e squared. So the negative sign will be cancelled. So tan alpha is equal to 2e divided by 1 minus e squared. So what is alpha? Alpha is equal to, this is tan inverse of 2e divided by 1 minus e squared. Anyway, by using the calculator, definitely we can find which angle it is, right? We know the value of e. E is a constant available in the calculator. First we find 2e by 1 minus e square, get an answer, take the tan inverse of that, you will get the exact angle. All right, then let's go to a different question now. So the next question is this one. Okay, so first curve r equal to b, and the second curve is r square is equal to a square cos 2 theta plus b square. Oh, sorry. So let's start with the first function, that is r is equal to b. So r equal to b, this means I can I don't have to take a log, right? It's fine, I can still take this. So log r is equal to log b. So 1 by r dr by d theta is equal to, differentiation of this is 0. So this means left hand side I am going to call it as a cot phi 1. Cot function is 0. So cot function is 0 only for one angle, that is phi 1 is equal to cot inverse of 0, that is equal to 90 degree. So pi by 2. Okay, then let's go to the second function. The second function should be say like this: r square is equal to a square cos 2 theta plus b square, right? So let's take a log on both sides, that is 2 times log r is equal to log of this whole thing, right? So log of a square cos 2 theta plus b square. So it's the right hand side is a sum, so I don't have a facility to take the log of two different terms, right? Now next step, we know that we have to differentiate. So this is 2 divided by r, 2 into 1 by r into this is dr by d theta should be equal to, we'll write 1 divided by a square cos 2 theta plus b square, multiply this with the differentiation of the denominator, which is nothing but there is a square which is constant. I'll write this as it is, a square cos 2 theta differentiation is minus 2 times sine 2 theta. So a square can I cancel? No, sorry, I cannot cancel, but if I divide this by a square I can do this. Yeah, I'll do that. Okay, so a square, I'll cancel this. This is going to help me out. So on the left hand side I have 2, that 2 will cancel with this 2. So now 1 by r dr by d theta is nothing but say cot phi 2. So cot phi 2 is equal to minus, I have sine of 2 theta over there, minus sine 2 theta divided by, this is cos 2 theta plus b square by a square. Now this is the cot phi 2. So you see here, this is a different type of problem where I got a phi 1 directly. Phi 1 I have the answer. Okay, but for phi 2 I don't have. Right? For phi 2 I don't have an answer, I have only cot phi 2. Okay, now anyway our procedure still remains same. I need to find out the point of intersection. So at the intersection point I need to equate both of them, right? So you see a difference here. The functions are same, that is true, but in the previous cases both were r is equal to something. Now you see that the first function is r equal to b and the second function is r square equal to something, right? A square cos 2 theta plus b squared. Now I cannot equate both of them directly because first one is simply b, which is r. So I have to take the r square, then only I can equate r square equal to b square. Now you equate both of them. This implies the b square is equal to a square cos 2 theta plus b square. Alright? Only under this condition they are equal, because one function is simply r, second function is r square. I cannot equate them. I have to equate equal terms only can be equated, correct? So this means you see the b square and b square will cancel. That means a square cos 2 theta is equal to 0, correct? So this means cos of 2 theta is equal to 0. Anyway, a square has no meaning now. It gets cancelled. So cos of an angle is 0 means cos 90 is 0. So 2 theta is equal to cos inverse of 0, that is equal to pi by 2. So what is theta? Theta now 2 goes to the other side and you get pi by 4. So at theta equal to pi by 4, both the curves, right, both the curves are intersecting. Correct. Now, first one, phi 1 I already know. I don't have to calculate that. Let's directly calculate the phi 2 value. So, we know that already we have calculated this. Cot phi 2 is equal to, let's just go back and check. Cot phi 2 is equal to this one. Alright, minus sine 2 theta, alright, whole divided by, this is cos 2 theta plus b square by a square. So substitute, and now I need to put theta is equal to pi by 4. So when that happens, this is minus sine of 2 times theta is pi by 4, so this becomes pi by 2 all divided by cos of 2 into pi by 4 plus b square by a square. So 2 cancels with this is 0. So this is sine pi by 2. I know that sine pi by 2 is 1. So numerator is minus 1. So denominator cos pi by 2, which is 0, plus b square by a square. Okay, so b square by a square, this is minus of a square by b square. This is cot phi 2. Okay, now I can calculate the angle now. So this implies the phi 2 is equal to cot inverse of minus of a square by b square. But we have one property from trigonometry. If a cot inverse is negative, you can write it as 180 minus the term. So this is pi minus cot inverse, because cot is negative only in that case. Okay, a square by b square. So pi minus this number. Okay, all right, we got this. That is phi 2. Now let's calculate the angle. So alpha is equal to magnitude of phi 2 minus phi 1. It's magnitude. Okay. So this implies now alpha is equal to magnitude. What is a phi 2? If you look at the phi 2 and phi 1 value, so this is how it looks like. So alpha is equal to phi 2, let's substitute, that is pi minus cot inverse a square by b square minus phi 1. If you check, we got pi by 2. That's the alpha. Okay, let's simplify this further. So this is equal to, we have pi minus pi by 2, which is simply pi by 2. Pi by 2 minus cot inverse of a square by b square. So 180 minus an angle is nothing but it's a tan function. So cot inverse can be replaced by simply tan inverse. So this is tan inverse of a square by b square. So from the basics of trigonometry, if we apply